Hi guys, welcome back. So we are still looking at classifying some numbers, right? This is all about what a number is, how do we classify it based on the properties that that number has at the time, and how do we play around with numbers? How do I then make this number, or rather say this one is different from that one? What makes them different? But so far, what we've picked up, by the way, is a natural number is a whole number, but a whole number is not a natural number. I will repeat. A natural number is a whole number, but a whole number is not a natural number. So please keep that in mind. You will see where that comes in. So now to continue with our set of numbers, we have, are all the numbers that we have considered to be whole numbers, right? If they are not whole numbers, what then do we then call them? So if I use the operation of subtraction on whole numbers, what will that do? So for example, if I say 2 minus 3, this gives me negative 1, right? If I say 5 minus 4, this gives me a positive 1. If I say 5 minus 5, this gives me a 0, right? So now do you see, as soon as I start introducing the subtraction operation, now I am getting negative numbers, positive numbers, a 0 there. What exactly are these numbers classified? That's what we need to think about. So we have what we call integers, right? The mathematicians classify them as integers to mean that these are both the negative and the positive numbers, and also the non-positive or non-negative numbers. The symbol that we use is more like a Z, although it's not necessarily a Z, right? And this simply means element of integers. Now the symbol Z comes from the German word which is Zahlen. I hope that I'm saying it correctly, although in German I wouldn't know how to say it. So Zahlen. So Zahlen, which really means number. And this is what they tried to describe this Zahlen number of ours as, right? They are saying these are all positive numbers. These are not positive, or the non-positive or non-negative numbers, and also these are all of the negative numbers. So what exactly are we saying now? We normally use what we call a number line for this one, right? 0, and then I have the negative side, this side, I have a positive side. So all of these numbers that are here are considered to be integers, right? So that's how you look at the concept of integers. They are both negative and positive and non-positive or negative numbers. And then the operations that we use are only limited to multiplication without going to division. So it's plus, minus, and multiplication. But then are all the numbers that we have integers? Now, firstly, before we even answer this one, I want you to now think about this, right? When I started, I said natural numbers are counting numbers. We found that these counting numbers can also be classified as whole numbers, but we must include 0 in order to make whole numbers different from natural numbers. Now we are saying all those natural numbers and all those whole numbers can be considered as integers when you make them negative, and when you leave them as positive, and when you leave them as non-negative or positive, which is 0 in that context. But now, are those the only numbers that we have? If not, what else do you think we have? We've only used 3 operations so far. What about the 4th operation that we use in our mathematics, which is division? What does division give me now? What kind of a number is division introducing to me? What type of a number, rather? Let's quickly look at that. So, what we know here is we have what you call rational numbers. Now, rational numbers will be any number that can be written in the form of A over B, where A and B are integers and B is not equals to 0, right? Meaning if they are integers, it means they are also counting numbers, which is the natural numbers, and they are also the whole numbers that we are talking about, right? But our denominator cannot be 0. And we need to think about why is our denominator not allowed to be 0? What does that do for us? As I'm saying that, I want you to press your calculator and take any number, divide it by 0, keep it at that. I promise we're gonna just analyze that just now. So the operations that we use then here are inclusive of the division, right? So a rational number is a number that can be written as A over B, where A is an element of integers, B is an element of integers, but B cannot be 0. This is very important, guys. And I said you must find what my answer is, because we're going to talk about that just now. Our symbol for rational numbers is Q. Now, the rational numbers, they are said to include the integers. These include proper fractions, so 2 over 4. They also include improper or mixed fractions, so this will be 3 over 2. And they include what we call terminating decimals. I will explain what that is, and then they also include the recurring decimals, which I will explain just now. So when you talk about terminating decimals, these are decimals that have a finite number of digits after the decimal point. So you can count how many decimals are there, and those decimals are normally very few, right? But if you have a 3 divided by 10, right? Now there's a lot of decimals, because this is going to be 0, something, 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 right? 1 over 3, I mean. So not 10, this, because this will just be 0 over 3. If I have 1 over 3, right, this will be like 0.333333333333. What does that mean? That therefore becomes what we call a recurring number, right? Recurring number means there is a specific pattern that the decimals are going to follow after the comma, right? It's either it becomes the same number throughout. You can see my ellipsis means this is continuing indefinitely, or it can be just a pattern of numbers that are repeating itself, and then they repeat the same way. So 2, 3, 2, 3, 2, 3, 2, 3. So that will be an indefinite continuation of numbers. Now, the last thing that we need to try and look at here is to try and show that this 0.23232323 is a rational number, right? What does that simply mean? It means that this number can be written as A over B, right? Where B is not equal to 0. If I can do that, then I would have shown what they want me to do here, right? So, by the way, this is a very interesting thing to do. So, firstly, we introduce something here. We say, let's let this 0.23232323 to be equals to x, right? It doesn't really matter how many 2/3 I have, because they are recurring. So, if I omit 2, it doesn't really make a difference, because it is continuing indefinitely. And then it means that I will have x is equals to 0.23232323, right? If I was to multiply this by 100, why am I multiplying this by 100? Because I'm trying to make it to maintain the shape or the pattern that is after the comma, right? Because if I multiply by 10, only the 2 will go that way, and then it will disturb the pattern that side. So if I multiply by 100, it will be 100x, I mean, on both sides, right? Which will be 23, 23, 2, 3, 2, 3, 2, 3, right? And then from there, I'm going to say maybe this is my equation 2, and that's my 1. So I will say 2 minus equation 1, which will then be 99. X is equals to, and then on the calculator, we'll quickly just try and subtract this. So we'll say 23.23232323 minus 0.2323232323, right? And you'll see this will only be 23. So as a result, this is 23. If I divide there by 99, divide there by 99, I will then have X is equals to 23 over 99. Then to prove this on the calculator, you just divide this by 99. And it will then go back to what we initially had. So that's how you then play around with these numbers and convert them. The very first thing you need to do is to introduce X and then multiply by a number such that it can maintain the pattern that you had there. And I'm going to show you at a later stage one that does not adhere to the pattern, which is what we call the non-terminating and non-recurring, but we'll look at that at a later stage. So this is how you can convert a rational or a recurring decimal to be a rational number. All right, guys, we've come to the end of this particular segment, but we're just going to take a quick ad break because when we come back, we're going to have some more work that we're going to look at in terms of classifying these numbers that we are talking about. So please stay tuned and don't go anywhere because I'm just going to come back after this ad break.